Welcome to Study Loop.
This is the answer to Chapter 13, problem number 18 from the Smith Organic Chemistry textbook. And this problem is asking us to look at 6 molecules and to predict what kinds of IR signals we're going to see. And so to start, so each of these molecules has CsP3H bonds. sp3 carbons bonded to hydrogens. And so all of these molecules are going to have peaks at 2850 to 3000 wave number. And so for A, that's actually all the peaks that it's going to have. Remember, IR tells us about functional groups, and there are no functional groups in molecule A. So it's only going to have those CsP3H peaks. So then when we look at B, the functional group that we see in B is an alcohol. And so alcohol is going to be a broad signal at 3200 to 3600 wave numbers. And so I've written where the peak will be in red, and I've written the functional group that it represents or the bond that it represents in blue. And so moving on to C, the only functional group in C is an alkene, a double bond. And so remember, as long as there are hydrogens on any of the carbons involved in a double bond, you're going to get two signals. You're going to get the signal for the carbon-carbon double bond, which is going to show at 1650 wave number. And you're also going to get the signal somewhere between 3000 and 3150 wave number for the CsP2 hydrogen bond. And so that's for C. Again, there will be two major peaks in addition to the peak that all of these have for the CsP3H bonds. So moving on to D, the functional group in D is a ketone, and we know ketones show somewhere in the vicinity of 1700 wave number, and so that's the answer to D. And then moving on to E, E is a little bit more complex of a molecule, and there are two functional groups in E. So there's a carboxylic acid and there's an alkene. So the alkene is going to be no different than the alkene in C was. So the peaks are going to show, maybe not at exactly the same spot, but certainly in the same vicinity, in the same range. So again, CsP2H bond 3000 to 3150, carbon-carbon double bond 1650. Now, from the carboxylic acid, you could look at this and say, well, it's just a carbon-oxygen double bond like in a ketone, and then an oxygen-hydrogen bond like in an alcohol. But that's not quite right. And so the carboxylic acid, the carbon-oxygen double bond is going to show around 1700, but it will be different than just a ketone would be. It will probably be shifted down a little bit, so maybe 1690-ish. And then the OH bond of the carboxylic acid is going to be mostly in the same range as an alcohol would be, but it's a wider range. So instead of 3200 to 3600, you'd see it somewhere between 2500 and 3500. And then lastly, F. So F has, let's see, 1, 2, 3, 4, 5 functional groups, really, if you count the aromatic ring as a functional group. And so the alkene, like we've talked about in E and in C, the alkene is going to give us these two signals, 3000 to 3150 and 1650 for the two different types of bonds associated with the alkene. The alcohol here, really it's a phenol since this is an aromatic ring, but it's going to show, where we would expect an alcohol to show, 3200 to 3600 wave number. And then the aromatic ring itself is going to give us signals at 1500 and 1600 wave numbers. And so there is an ether in this molecule as well. But remember, we are ignoring ethers for the purposes of IR. And so there will be no signal associated with that ether. And lastly, we have an amide here. And so the amide, similar to the carboxylic acid, is going to give us a carbon oxygen double bond peak around 1700. Probably not exactly 1700, though. And then the nitrogen hydrogen bond from the amide is going to show around the same range as an alcohol, 3200 to 3500. And so that is the answer to chapter 13, number 18.